Hello, my name is Stephen King and I'm investigating the application of environmental economics and management science in effective environmental decision making. During the course of this presentation, I'll explain my current research project, how to choose economic valuation and optimal planning of river barrier mitigation actions. The final outcomes of this project are anticipated to be of direct relevance to river managers and policy makers responsible for ensuring the ecological quality of our rivers and meeting regulatory obligations. I will begin by explaining the nature of the issues my research investigates. River systems play an essential role in the transport of organisms and matter through the landscape. However, as a society, we have extensively modified these systems, and approaching 80% of the rivers in the northern third of the world are now impacted by the construction of river barriers. River barriers such as dams, weirs and culverts provide substantial socio-economic benefits such as power, flood suppression, water supply, our transport network and navigation. However, these benefits have been obtained at significant environmental and social amenity costs. In particular, river barriers fragment the continuity of the rivers, obstructing migratory fish such as salmon from reaching spawning grounds or the resources necessary for the other stages in their life cycle. In addition, barriers isolate local resident fish populations, often leading to local extinctions as the fish can no longer reach the resources they require and cannot be repopulated by the larger meta-population of the river system. The overall effect is the variety of fish, and the number of fish in rivers reduces as the number of barriers increase. This affects not only the fish, but a number of other animals in the river ecosystem. River barrier removal or mitigation action is now seen as an increasingly effective river restoration technique. The benefits of mitigation action and increasing the variety of fish and their number in rivers includes improved recreational amenity, improved fisheries, improved river biodiversity, improved wildlife watching, and stimulation of investment due to increased amenity. The broad aim of my project is to develop a framework that will ensure cost-effective and optimal river restoration strategies that can be readily developed for river barrier mitigation action in river systems containing hundreds or even thousands of these barriers. In order to inform this framework, I will pursue two avenues of research. The first is to determine the social benefits of river barrier mitigation action in monetary terms. As these benefits are not captured in markets, the project will research and develop a cutting-edge, non-market valuation methodology appropriate to this scenario. This will allow the value the public places on these benefits to be estimated and identify if river barrier mitigation actions are economically rational to pursue in the short term. This is of fundamental importance to regulators in understanding their responsibilities under legislation such as the Water Framework Directive that allows derogations from their general requirements where this is not the case. This allows public funds to be targeted at policies that best increase the welfare of society. The second avenue of research will be the development of a prioritisation methodology to ensure any set of barriers targeted for mitigation action is optimal and therefore provides the best value for money. Under the current system of prioritisation, the Environment Agency have identified 2,500 barriers for mitigation action at an estimated cost of £540 million. This prioritisation exercise has considered each barrier in isolation rather than part of the river network. As a relative benefits of mitigating a given barrier change, as others in the river system are mitigated, this £540 million may represent poor value for money. The project will develop a more sophisticated prioritisation tool using optimisation techniques. These techniques allow a river system to be represented as a mathematical model. The model is solved optimally by finding the subset of barriers to mitigate that maximises the benefit of mitigation action subject to a given budget. The model will differ from the current methodology as it will account for how the system dynamically evolves as each barrier in the system is mitigated. The project will ultimately integrate research into estimating society's valuation of river barrier mitigation benefits into this optimisation model as a single framework. This will allow the value of such benefits to consequently be maximised across any given river system at any given budget level. This framework will provide an essential insight to a wide range of practitioners involved in water policy and river management. At both the national and local river basin levels, the framework will allow determination of the benefits of river barrier mitigation actions for given ecological targets, thereby identifying where restoration costs are disproportionate and not cost effective. This will allow regulatory authorities to best plan how to meet their obligations under legislation such as the Water Framework Directive. Also, as the framework ensures that the subset of barriers selected for mitigation action is optimal, it will allow river managers to determine optimal trade-off curves for river restoration against costs. This will ensure regulators undertake river restoration action in an economically efficient manner, making the best use of public funds. I'm Stephen King, thank you for listening.